There we go.
Breaks optional.
Yeah!
Wow.
Okay.
Welcome to another exciting installment of the Breaks Optional show.
Breaks optional.
Uh,
So strong, bad.
this is the show where we talk about whatever we talk about. It's usually very interesting stuff to the three of us.
And we usually go on ad nauseum until
Yeah.
we're talking about puke.
Well, you know, Jennifer did make an observation a while back that every time that I got together with my friends, Carson and Wade and Adam, that every conversation would always devolve into puke and poop.
Including this one.
Well, at least you're
Already off to a
consistent.
good start.
So, yeah.
We got to cover our 10 to 14 male demographic.
Right. We're just bringing them in. Wait, we got to talk about Minecraft some more then.
Mine.
Wait, do they talk about Minecraft anymore? What's that game now with that silly
Fortnite.
dance?
Fortnite.
Fortnite, yeah, there we go.
Or as I call it, 2 weeks.
We're old.
These kids playing their Fortnites and their Minecrafts. Back in my day, we didn't have none of that.
Right.
Just Duck Hunt.
I'll tell these kids all about how Mega Man 2 is the pinnacle of video game music, and they can't argue that.
It's like Mega Man 2. What?
Mega Man.
Mega Man.
Yeah, Mega Man 2. There never was a greater soundtrack for a video game than Mega Man 2. All right. Anyway, moving on to our topics. John, I hear you've got something exciting this week.
I've got news, that's for sure. So a little bit of background on this piece of news first. I'm actually going to diverge a little bit from my usual topic, which is VR, and I'm going to talk a little bit about retro gaming for
Wait a minute,
this.
is this allowed in your contract? I mean, I thought we brought you on for VR.
Oh, well, let's see here. I burned my contract.
We'll allow it.
Okay.
Excellent. So we're talking about Mega Man 2 some more.
No. Actually, we're going to talk a little bit about Duck Hunt.
Duck Hunt.
Back in the day, there's obviously I suspect most people know what the Nintendo Zapper is. That you can see it up here on my poster if you can. I don't know if you got enough detail.
Can you tip your camera up
tip your
momentarily?
camera up.
All right, here we go. I'll try not to make you sick.
Hey, Robbie the Robot.
Oh,
So
there we go.
Yeah, you got Rob the Robot there. You got the NES system, and you've got some hand holding the Nintendo Zapper.
I don't think our Nintendo came with a hand.
What's that?
I don't think our Nintendo came with a hand.
Yeah, you missed out. It was great. But the way that the Nintendo Zapper worked was really ingenious at the time. The Zapper had a little light sensor on the inside of it, and it could tell exactly what point the CRT screen would be at in drawing the pixels on the screen. And the way that it would do that is because the CRT screen just has, see if I can remember any of the names of these things, because it just has one line of pixels that's being refreshed at a time. The Nintendo system would send a completely white screen to your TV, and then your TV would start to draw that on there, and the Zapper would detect when it sees the line being drawn. And at that point, it would say, it would recognize that point, and it would receive a signal from the screen telling it which line and which column it was at. And that's how it knew where you were pointing at the screen.
Oh, I thought that when I was looking at it, I thought that it blanked the screen when you pulled the trigger and had like a little white square where you were supposed to be pointing the gun, and if your gun picked up a light signal, you got a hit. If it picked up a dark signal, you didn't get a hit. You're saying it was more complicated than that?
Yeah, there were two ways that it worked. Some of the games they did that. Duck Hunt is one of those that worked that way. You would pull the trigger, the screen would go black, and there would be white squares wherever there was something that you could shoot on the screen was. And again, it wouldn't just recognize a square on there. It would recognize when you're shifting from no signal to all of a sudden there's a light showing up. And that's how it knew if you were pointing in the right direction.
Oh.
Other games, I believe, if I understand correctly, it would just flash the completely white screen and pick up when you finally see the white appear on there. So there were two ways that it would work.
Oh, that's interesting. Huh.
Hey, John, do you remember when I disassembled my Zapper and I just experimented by arranging and rearranging and removing lenses, and I found an orientation where every time I pulled the trigger, it would hit a duck as long as the Zapper was pointed in the general direction of the television.
Yeah, I remember that.
So I cheated because I wanted to see if there actually was an end to Duck Hunt, and we went on for hours. And I don't think there is an end because we just sat there. Ducks would just fly out, and we'd pull the trigger, and they'd die. And we did that for hours and hours.
Duck genocide.
Yeah. Yeah, we were like, those cowboys riding on the train, shooting all the buffaloes and stacking the skulls up, except with ducks. That's what we were like.
Digital ducks.
Yeah.
Well, I think that Duck Hunt was based. I don't know if it was based directly off of an arcade game, but the game itself was based off of the principles that drove arcades at the time. And so your goal was not necessarily get to some end, some story. Instead, it was just rack up as many points as possible.
Get the high score.
Right.
And win the adoration of your peers.
High scores. High scores, in my humble opinion, are a crutch for lousy gameplay.
That's why they've gone away for the most part. Maybe for the all part. I don't know.
I don't know. I quit playing games about 20 years ago. I quit gaming.
Yeah, me too.
Well, I'm like a recovering alcoholic has to not like go and hang out in a bar. That's like me with video games. I have to just not like have video games around. Otherwise, I'll just be throwing all of my time down the black hole, never to retrieve it again.
Well,
Speaking
getting
of
back
black
to the topic at hand.
Oh yeah.
We were talking about the NES Zapper and the way that it worked based off of old CRT screens.
Yeah.
Well, that's great and all. It worked really well for the time that it was created, but there was a problem when we switched to LCD and LED type screens because they don't work that way.
Oh wait, so a Zapper won't work on a modern television?
Nope. If you want to hook,
I didn't realize that.
Yeah, that's a huge problem for retro gamers. Is if you want to be able to play, there are a lot of games. If you want to play them as pure as possible, you get an old CRT screen, hook up an old NES system, and you play it on that with the CRT screen because the refresh rates are quicker. There's a lot less latency. Well, maybe the refresh rates aren't quicker, but there's a lot less latency that's going on.
Huh.
And so people who are going for high scores or speed runs or stuff like that will oftentimes use a CRT just for that reason.
And they only listen to their music using vacuum tubes.
Thanks for that, Elroy. Yes. But one of the reasons why they do that also is because the Zapper won't work on any modern screens. But there's been a lot of experimentation going on, and people have tried different things. And there's this company called Hyperkin who they make a lot of retro gaming devices, retro controllers, clone consoles of old machines that you can play your NES carts in, stuff like that. Well, this last CES, they announced that they have they have a zapper that will work with LCD screens specifically and with Duck Hunt.
Oh wow.
I love it. It's so funny to me that we put so much effort into recreating old and obsolete hardware and software. But like the pains that people go through to emulate video games, it blows my mind. Like John, I'm sure you know all about this. Like some people, like there are different strategies for emulating games, and some people are purists and they emulate the limitations of the hardware with software. And it's crazy to me. Like, kind of blows my mind that people put so much effort into it.
Yeah, that's like somebody, I don't know, like taking old guns from like Eastern Bloc countries and taking hours and hours fixing them up.
Yeah, who would do that?
I don't know.
That's crazy.
People.
I didn't say that I'm against them doing that. It just kind of blows my mind, right?
Yeah.
For any of you not familiar, that is what Damon uses his time for. Instead of video games, is taking old AK-47s from Eastern Bloc countries and refurbishing them or modifying them.
Yeah, it's fun. It's a tangible link to history. Oh, okay, I get it now all of a sudden. People are making links to history except video game history. Okay, I get it.
Yeah. You're right. People go through great lengths to try to emulate it just the way it was, exactly as they had it in their childhood. And then you have people who are like, well, forget some of those limitations. Let's try to break through and do more than what can be done there. And there are pros and cons to each of these ways that work, where you have software emulation, which is one of the most common ways that people play old retro games. Just so you know, I don't support privacy or piracy. I don't support piracy. That's right.
If you see somebody peeking in your window.
Thank you, Google, for all the money you gave us.
I don't support piracy. I believe that you should go out and actually own you should own the games that you're going to emulate. But there's some cool things that can be done with emulation. And then you have people who go through and try to emulate what's been done at a hardware level just because they want every little nitty-gritty detail to be just right. And it's crazy what they go through, like making a zapper. Anyway, that's all I've got for this.
Nice.
Okay, cool. Well, mine is, I think, going to end up being fairly short. I've got a topic that's kind of itching in the back of my brain that it's going to have to be for a future episode. And
tease it. No spoilers.
Is it what?
Tease it. No spoilers.
Yeah, I'm going to tease it. For our viewers that don't know our in real life history very well, Damon years ago converted a Suburban to run on vegetable oil, and in an episode of Mimicry is the sincerest form of flattery or something, I also did that with my SUV, and in the process of doing that, I decided to do the calculation and see how many acres of corn we would have to grow in order to run the nation on biodiesel or ethanol. And so,
can we grow corn on Mars yet?
Potatoes, I think, is what it's limited to.
Oh, yeah.
Potatoes and human poo.
Wow.
Oh, that's right. I saw the documentary, The Martian.
Oh, yes.
Yes. Yeah. So in a coming episode, I'm gonna do calculations, but I'll try to make it not feel like a math class, and show how many acres we would have to grow in order to do biodiesel. But I'll probably also bring solar power into it because I've been fascinated with that too. Yeah, I'm not your typical environmentalist. Is that word even in vogue anymore? I don't know. But I do like efficiency. I love efficiency, and I I want I always like to see. It's one of the reasons I like diesel cars is because they're so thermodynamically efficient and
Yeah.
stuff. So anyway,
Well, you've got my attention now, Elroy.
yeah. Well, you're just gonna have to wait.
All right.
No.
Um, okay, so I've got to let me bring up my notes here real quick, and there we go. All right, so this. Hold on a second. So the topic that I've got for today is uh, a radio telescope, and this kind of encroaches on Damon's usual subject matter. But
We're
this
just breaking all sorts of rules today.
um, but I did think about going back to the solar system that was found a couple of years ago that had like 7 planets in its Goldilocks zone. But we already did that on a previous episode. I might come back to it if we don't get one of those edited and up on.
Trappist.
Trappist, yeah.
Yeah.
Trappist 7, yeah.
Nice.
So anyway, this radio telescope is called CHIME, CHIME, and it is different than the radio telescopes, like in Contact, that are a dish that they pan and tilt around the sky in order to, try to home in on a signal from a UFO or or just radio signals coming from the galaxy. This is it's a series of troughs. It's 4 parabolic troughs, and they're each 100 meters long, so as long as a football field. And so the reason why this is interesting is because rather than turning the dish to look towards the signal, these troughs can pick up radio waves from a large portion of the sky, a very large portion of the sky. And then they use software to home in on certain, like on a small angular extent of the sky. So it's basically like a giant radio camera, if you will. So they can make radio signal pixels, and and one of the reasons why this is cool is because they can catch these transient burst events. And Chime is specifically designed for picking up signals that happen really fast and then go away. And the reason why that's interesting is because they think that the things that create that are giant magnetrons, basically. So if you've got a couple of, or like a neutron star with a magnetic field that's spinning around very fast, you'll pick up a series of really sharp signals. They'll go boof, 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 and they think that say another thing that could cause that is 2 neutron stars orbiting around each other very fast. There's even some suggestions of alien spacecraft, which I'm not saying it's not possible. Just
remember what they say on PBS Space Time. It's never aliens until it's aliens.
That's probably true.
That's an interesting channel. What am I doing in here touting other channels? That's a terrible channel. Ours is better. Watch this one.
Well, we don't create original content. We just report interesting things that other people have done.
Well,
And
okay.
we're using this as an excuse to justify the hours of YouTube videos that we watch during the week.
Time to start talking about whose line is it anyway.
So anyway, the way that this telescope works is rather than steering the dishes, they take all of the signals in, and then by looking at the timing, the relative timing between the signals hitting the dishes, then and using heavy computational power, then they can suss out what direction the signals were coming from. So they're able to start doing imaging, and they can pick up these rare transient events because they're not just pointed at one narrow section of the sky. They don't know where these transient blips are going to come from. So since they're surveying a large area of the sky, then they're more likely to pick up these blips. And they picked up 13 of them just in their calibration period when they were setting the telescope up.
Oh, very cool.
And let's see. And one of those that they picked up was a repeating signal, which is the one caused by a quickly spinning neutron star. And a repeating transient signal like that has only been picked up one time before ever by another radio telescope. And they picked this up within the first few months of fiddling.
Oh, no way. That's cool. I have a lot of questions here. This is some cool stuff. I love when you can take something where you have to have very precise, like you have to mechanically be pointing something in a certain direction, and then all of a sudden you can switch that over to a software end, because there's so much you can do when you take away the need for moving parts. And so that to me is just really cool.
Right. So just think if you could do that with light, then you could well in this is I believe this is how synthetic aperture radar works, just kind of in reverse. They're controlling the phase. They've got a series of radar emitters that are in an array, and by timing when they send out a pulse from each one of the emitters, they can steer the radar beam. So rather than swiveling the dish, you like if you want to point the beam in that direction and you've got a series of emitters here, then you fire this one, then fire this one, this one, this one, this one, this one. So your wave comes out looking like it's coming out at an angle. So synthetic aperture radar. Yeah, it's cool stuff. And that's kind of how holography works too, which I'm going to be working on holography again here in a couple of weeks.
Oh, exciting.
I'm excited about that.
You work on the holography. I'll work on our capture system.
Excellent. All right, so that's all I have.
Oh, very cool. Well, I've got two space exploration news tidbits today. I'm sure you guys heard about the Chinese chang'e moon probe.
Oh yeah,
that's very exciting. So okay, so previous to this point, no country has ever put a probe onto the far side of the moon. Of the probes,
it's not the dark side of the moon?
Okay, and that's another tidbit. It isn't actually the dark side. The dark side of the moon is a cool
Pink Floyd album.
The far side of the moon, because the moon is tidally locked to the Earth, meaning the braking force of the tidal force, the side of the moon that's closer to the Earth, is experiencing more gravity than the far side, right? And over the eons and millions of years, that force has slowed the spinning of the moon down until finally it came to a stop. And so now the same side always points towards the Earth, but that doesn't mean that the same side is always pointing towards the sun.
Right.
A moon's day is, roughly 4 weeks, 28 days about. So you get 14 days of daylight and 14 days of darkness on the far side of the moon. Now the cool thing about this probe is that since it is on the
14
far
Earth
side of the
days.
moon,
Technically,
what's
it's
that?
one. I said 14 Earth days.
Earth
Technically,
day.
it's one moon day.
Correct. So the Chinese have some very cool. They've got some radio receivers on this probe because all of the Earth radio chatter, is blocked out entirely by the moon. So they're able to listen to the cosmos without all of the racket coming in from the Earth, coming in from our cell phones and from a radio station and
from AM talk political news stations.
Right? They can block all that out by the moon, and so they get a blank canvas that they can actually hear what's going on a lot easier. But that presented a whole bunch of challenges in and of itself, because you can't get radio signals to the far side of the moon at all.
Because they travel in straight lines, right?
Yeah, line of sight, yes.
Mostly.
It can. So yes, it can bounce off of objects. It can bounce off of matter, gases, but hi, Bridger. Yeah. But the cool thing that they had to do, they set up a relay station in the Earth Moon L2 Lagrange point. Okay, guys, you need to be quiet. So a Lagrange point is a point in an orbit between two objects.
So I pronounce it Lagrange, but I quibble.
Okay, Lagrange. Lagrange is also a cool song by ZZ Top. Anyway, so you can't just go and park something in outer space in our solar system. You could go, if you go out there and try to park it, all the objects out there with all the gravity wells are going to make it start rolling towards them, and until one of them either flings it out into nowhere land, or one of them pulls it into itself. Okay. Or
Bridger.
or till one of them captures it. So they figured out that there are several points that you can park an object between two big gravity wells. So
where it kind of gets balanced out in between them.
Yeah, and some of the Lagrange points, whatever you want to call them, Lagrange points. Some of those points are stable, meaning if you do a good job of parking it there, then your object stays there, and if it starts to drift, then it gets pulled back into the Lagrange point. Some of them are unstable, where if you start to drift, you'll start drifting faster and faster. It's like you're parked on top of a hill, right?
Oh yeah.
So some of them are like you're parked on top of a hill. Some of them are like you're parked in the bottom of a trough. And
so that makes me wonder a question.
Yeah.
Do you have to have a parking permit for a Lagrange point? Because what if France comes and says, we've got a better science experiment that we want to do. We want to move your satellite out of the Lagrange point and put ours there. So who solves that?
Right. No, I've wondered that too.
Do you get to plant your flag in the Lagrange point and says, this is our Lagrange point. Go find your own.
And I've also wondered, is it an area, or is it an actual point, like an actual zero mass, zero area point.
Oh,
You know,
yeah,
or
like how big, what's the definition of the Lagrange point?
yeah. And when we're talking about engineering, we don't, usually when you're talking about engineering, there's you don't have to worry about exactness usually. So even
You
if
just
it
have to be good
is
enough.
mathematically a point, is there effectively an area like a parking lot? Is it a
Right.
parking lot, or is it you actually have to balance your car on top of a fence post?
Or is it in the bottom of a hole, a
You
dip?
can stack a whole bunch of satellites right in there.
Are they just gonna
So
get like slide on top of each other if you park them in the Lagrange point? Like scratch each other's paint and stuff.
Yeah, I don't know. I'm gonna have to do some more reading on this. But so what the Chinese did though, they parked a relay satellite in a Lagrange point, but I think it also was on the far side of the moon. But then they also had an orbiter. So no matter where this orbiter was, it could see the orbiter, the relay, and no matter where the rover is on the moon, it can see the relay. So
Oh.
I believe that's how they handle communication, so they don't ever lose communications with their rover. So this thing is packed so full of science, it's cool. So they've got the radio. Hey, can you shut the door, please? They've got the radio observatory equipment. They also have a seismograph that they set down, similar to what the oh criminy, what's that probe that we just landed on Mars? I forget, but that has the seismograph.
Uh-huh.
So they set the seismograph down on the moon looking for moonquakes, and this thing also has a little miniature robot, like a six-wheeled rover.
Oh yeah.
So there's the lander portion, and then there's the little rover portion, and they landed in a gigantic crater, huge crater. Scientists think that whatever object created this crater was large enough that it excavated all the way down to mantle on the
wow.
moon. So the area they picked was very intentional, because if it excavated mantle material, that means that we'll be able to do science, to look at and take samples of material that we'd never be able to get down to otherwise. And we'll be able to tell more about the inner workings of the moon.
Interesting.
So,
That's pretty cool.
and another cool thing that another engineering obstacle was that since it is on the far side of the moon, and there would be enough latency, they wouldn't be able to joystick it down. They wouldn't have somebody sitting down on Earth guiding it down. So it picked its own landing spot and landed itself in an area that was clear.
Oh, nice.
It's some very cool science, very cool engineering that's gone into this thing.
There's so much there to unpack.
Yeah,
that's really cool.
And so it's exciting. We'll be seeing more pictures coming out in the coming weeks, and hopefully we'll get some of that mantle material. I can't remember. I've been reading so much about Mars landers and moon landers over the last few weeks that I can't remember if this is correct or not. But I think they're good. They're going to take some samples and return them to the Earth.
Oh.
I can't remember. I might be misinforming everybody here. I'll have to double check.
Just make stuff up that sounds cooler.
I mean, that's pretty much what I do my whole life. So my second topic is that recently astronomers have discovered have been able to witness a supernova. So supernova is the death of a star. When a star finally, runs out of lighter elements and starts making heavier elements out of the lighter elements, its gravity starts to suck in all of the mass, and eventually, when there's not enough fusion material left inside to keep pushing out, to keep the pressure pushing out,
it's an
it
interesting
blasts.
balance.
It's a hydrostatic balance. A
Yes.
star is. It's so cool.
Because it's creating heat, which keeps it from collapsing, and also the radiative pressure.
Yep.
And as long as those are in balance, then it keeps creating heat and light. But it goes through some phases. Like a star at first burns hydrogen, it fuses hydrogen into helium, and then once it uses up enough hydrogen, then it goes to the next phase and starts burning helium and creating even heavier elements. And once it gets through that, then you get to a phase where it can't generate enough outward pressure anymore. It can't continue to fuse these heavier elements at a rate sufficient to keep the star from collapsing, and then we get to Damon supernova.
So the supernova, that's the dramatic part of a star's life, where all of a sudden the gravitational pressure sucks all of this matter in, and it starts compressing it and smashing it down. And depending on how big it is, depending on how much mass the star has, a lot of different things can occur. Sometimes it will compress down and smash down and explode into a neutron star. What's left over will be the compressed core that's just made out of compressed neutrons. Sometimes, if it's big enough, if the star started out big enough, it will suck down with enough force that it will collapse into a black hole. And this is up till June of this year, of 2018. That has all been theoretical and mathematical. In June of 2018, astronomers witnessed the birth of either a neutron star or a black hole. So we have witnessed supernovas before, but this time around, we're not sure yet if this one is a black hole or a neutron star. But the supernova happened much faster and much brighter than normal. And supernovae.
Yeah.
Supernovae
Go all Latin on us.
They're extraordinarily bright. When a star explodes, for example, it can give off more light than the whole galaxy can for a few weeks. But this object that's in a galaxy 200 million light years away, we've been able to watch it with optical telescopes and radio telescopes, and both Earth-based and space-based. And this particular object is giving off just incredibly huge amounts of X-rays and gamma rays in addition to the visible spectrum. So it's an interesting watch to see what happens and what comes of it.
Oh, that's interesting.
Another cool thing, it's giving off it when it exploded, it sends gases and material out into its galaxy in relativistic speeds. So about 20% the speed of light. It's sending iron, lithium, all kinds. It's sending pretty much anything lighter than iron. Well, and some things heavier than iron, but not in huge amounts, out into out into the galaxy in just incredibly high speeds.
Imagine all the superheroes being born currently.
Yeah.
Right. But did you know that astrophysicists believe that all of the heavier elements were not present in the Big Bang? That that in order to get stuff like gold and platinum and lead, stars had to go through a complete life cycle and go supernova, and that these heavier elements were created in this compaction, and then they were spread out into the universe or into their galaxy by the explosion. And then those materials then were incorporated into new solar systems, and so they were in the accretion disks of these solar systems that started to accrete and aggregate into planets and the stars, and that's why our planet has these heavier elements, is because it's the stuff that stars are made of, from supernovas.
That's pretty cool to think about, that, you know, the material inside our bones and our blood is old used up star fuel.
Yep.
We're just star garbage.
It's like the stuff that you scraped out of the bottom of the wood stove.
We're star ashes. Yeah.
Star ashes. We're star ashes.
More or less. Right. Oh, well.
So when I called you an ash the other week and you got all mad because you misheard, it was a compliment.
Oh. I'll keep that in mind.
I know. Well, that's all I've got for this week.
All right. So this is actually a little shorter, I think, than normal for us. But anyway, that was good. So our recap was old video games are new again.
Go duck hunt.
Radio telescopes that are steered without moving parts, and neutron stars and black holes. And,
we're just made out of star ash.
And the Chinese Chang'e moon mission.
I think
excited to be on the show.
Oh,
hey. Hi, Bridger.
Oh, and there's Blake in the background.
Well, thanks for tuning in to another exciting episode of the Brakes Optional Show.
We hope to see all you pieces of star feces next week.
Awesome.
Yeah.